Excellent.
Hey, what's up, and welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit, and joining me every week is my brother Pedro.
Good morning, everybody. I'm Pedro as Creative Tech here at Adafruit, and every week we're here to share 3D printer projects featuring electronics from Adafruit.
That's right. This is where we combine 3D printing and DIY electronics to make inspirational, glowy projects. Hello, everybody, and welcome to the show. We are hanging out in the Discord chat room. If you would like to join us through the show, you can say hello, ask questions, give us some gifts, banter, memes, all that fun stuff on Adafruit's Discord channel. And we got a link for you up here in our little social banner. Got a URL, discord.gg/Adafruit. All right. I'm going to share my screen.
Everybody
here.
hanging out in the Discord. Good morning, good evening, good afternoon. Good night to everybody hanging around all over the world. Good morning, Yanni, Mike P, Andy Calloway, Jim Hendrickson, Rosin, DeWester. Hello, hello.
We're also hanging out. Yeah, in the YouTube chat, the Facebook chat, and the Twitch chat.
Periscope.
I don't know about Periscope, but we're using StreamYard, and that brings in all the chats, which is really fun. So if you got a fun comment, we can actually feature it on the show here. So feel free to do that. I'm going to go ahead and get started with paying some bills. And if folks want to order some stuff today, you can use our discount code Scorpio Tree. So if you got something in your cart and you want 10% off your total order, this only applies to physical goods, but you can use a coupon code Scorpio Tree and get 10% off your order. We're going to hang out or mosey on over to adafruit.com/free, and you'll find out all the deals that are going on. For orders that are $99 or more, you're going to get a free half-size Perma-Proto board. For orders that are $149 or more, you'll get a half-size Perma-Proto board plus the KB2040. That's that dev board that's really great for keyboard projects. And if your order is $200 or more, you'll get the KB2040, the half-size Perma-Proto, and free ground shipping for UPS, and that's in the continental US only. And then if your order is $299 or more, you get the free UPS ground shipping, the KB2040, the half-size Perma-Proto, and a microbit version 2 from the BBC. That's a fun dev board that works with all sorts of fun stuff. So for more details, go to adafruit.com/free. And then moving on over from the deals to jobs, if you go to the jobs.adafruit.com, you can look around for new jobs, new gigs, or if you are looking for people to help you with your project or your company, you can post up a job or your skills. So go to jobs.adafruit.com. There's some new ones. Adafruit, the New York headquarters, is actually looking for a junior bookkeeper, and that is a full-time position in the New York area on what do you call that these days? In person. So check that out. Let's see here. We also have, we want to let everybody know we have a newsletter that you can subscribe to. I have that here. The Adafruit newsletter. You can subscribe to this if you want to get informed on the new products that get added in the weekly. And that's adafruit.com/newsletter. Okay, what else do we have here? That's it. that's pretty much the intro that I want to share.
Sidetrack, we are on Periscope on Twitter. It is on the homepage. Twitter, if you follow Adafruit, we are right there. We're also on Mastodon too. We should get a graphic for that from Phil.
Yeah, that'd be nice. Yeah, you could follow us on Mastodon too. Adafruit, just search for Adafruit if you want to see what Adafruit's posting on Mastodon. Okay, Again, we got the coupon code Scorpio Tree. Yeah, I'm glad to have coupon codes again.
It's
cool.
nice little incentive.
Yeah, do we have any fun?
Comment, yes, but it's on Discord. I can't bring it in over. Wait.
I got it.
No, where is it?
Here it is. I got it. It's here.
No, the comment from Duester and Andy Calloway asking if there's going to be a pink Scorpio, and then that it should glow in the dark like real Scorpions do. That is a cool idea.
Yeah, you know, FR4 boards actually do emit light under ultraviolet already, so that's pretty cool. I think they do.
Test that out.
I thought they did. Yeah, I thought they did. Okay, fun. Any other cool stuff? Am I in the right chat room? Yeah, I'm in the right chat room, right? Broadcast. Yep. Oh, I didn't scroll down.
All over too.
That's funny.
Still getting used to the setup.
Yeah, I just had to scroll down. There you go. And we got nice cat saying what's up from Andy Calloway. So very cool. All right, you want to get started with this week's project?
Awesome project. This week we got a holiday tree. Finally, after all the holidays are over.
After all the holidays are over, you know, some people could say, "Oh, you're too late," but we'd like to say we're very early. We're about 11 months early. So if you head on over to the Adafruit Learning System, this is our latest guide
for Christmas. It's only 300 whatever.
360 days until the next Halloween. Yeah, so we were tasked to create a 3D printed tree-like structure from Lady Ada, and this was right as the Feather RP2040 Scorpio board was being developed. And the idea here is that you can use 8 NeoPixel LED strips to create this kind of art display with NeoPixel LEDs. And then utilizing the PIO peripherals from the RP2040 chip, you can do some really nice NeoPixel driving. So you can do background multitasking while you're driving your NeoPixel LEDs. And this project kind of just shows you simply how you can drive 8 individual NeoPixel LEDs and have them animate in different ways. And the cool part about this project is it's showing you how to use the CircuitPython library called the LED Animation Library in conjunction with the NeoPixel 8 library. So you can really hit those very fast frame rates, buttery smooth animations with those 2 libraries. And the demo code, big shout out to Jeff Epler, who wrote, he optimized my demo code to work and use the PIO peripherals on the RP2040 chip. And I just kind of designed and 3D printed this tree structure, which we'll talk about, and we can take a look at the Learn Guide here. But let me kind of just show off the tree here a little bit. I'll remove our screen and I'll just go single mode here. So I tried to keep it as modular as possible. So the way the NeoPixel strips are attached to these 3D printed slats are with just zip ties. I would suggest using white zip ties just because they kind of poke through a little bit. They don't blend in. If these were white, you wouldn't really see them. So that's one thing. But it's the NeoPixels strips themselves, these particular ones, there's only 30 NeoPixel LEDs per strip. So 8 of those makes a total of 240 strips. And what's cool about that is you can power all of these NeoPixel strips with just the USB port on the Feather RP2040. So here's the Feather RP2040 in a 3D printed case that snap fits together. And then I'm using a Perma-Proto board here. That way I can share all of the ground and voltage connections. And then I have soldered onto that Perma-Proto board 8 of these 3-pin JST cables. And these NeoPixel strips are really nice because they have this sheathing, the silicone sheathing. So it kind of protects it from the elements. It's water resistant, not waterproof, but it'll handle okay if like a splash of water hits it. They're insulated, so all of the exposed wires are insulated with these covers. And my favorite thing about these NeoPixel strips is that they already come pre-soldered with these 3-pin JST plugs. So you can use the 3-pin JST sockets cables to plug into those directly. So that's kind of the wiring setup I have here. And then the Feather, we talked a little bit about it last week. The Feather Scorpio has this 2x8 header pin. It's a little hard to show it here. I'll show it on the overhead in just a second, but I'm using this IDC cable that plugs right into that 2x8 header, making it a very easy to take apart. So I can dismantle this whole thing in less than 5 minutes. And the slats and the brackets here are all fastened together with M3 screws. And then this base here is 8 of these brackets that feature some really nice little socket hex nut cavities so that they capture the hex nut. And then I'm just using these kind of 10 millimeter long M3 screws to attach them together. And then the slats are just slotted into the brackets, the base brackets here. So everything is really easy to kind of take apart. Nothing here is glued. So it's completely modular and I can take it apart, which is great when you have holiday projects. You want to be able to break them down and save space. And that was like the whole goal for me when I designed this tree-like structure. And another shout out to Jeff Epler for his assistance on recommending some things on the design. So that's the project in a nutshell. There's a lot of room for improvement. If you want to like cover these up or add more NeoPixels, you can definitely scale it up. And that's just a little taste of the project. So I'm going to set it down over here. And let me bring Pedro back in. Do you have any comments about it? Or
yes, Mike P has an excellent idea. Could the slats be printed in such a way that the LED strips sit inside of them, like slide in, or the strips too thick?
No, you could definitely design the slat in a way where you could just slot them in. That would yeah, something like that. Like Pedro's showing.
Yeah, so these are just command strips for lights. I didn't know that. Light clips. So yeah, we could 3D print a thing like this where it's just, you know, you can see the side profile of that. That's all it needs to be.
Yeah, so that way you could kind of diffuse the strips, because right now they're kind of bare and open. So I think if you were to print if you were to design like a cover and a clip, it could actually cover the whole thing. I was really thinking about minimalism, and I wanted to be like as how do you say it, like as modular as possible. So if I design something to only fit these pixels, because you could actually use mini skinny strips, you can use side lit strips. They're all going to have a different thickness, and I did not want to constrain the tree to just a particular set of pixels. So that's one reason why I went with like, here's the easiest kind of most open modular way to do it. But that's definitely a great idea, and I'm glad you brought that up. But yeah, there's, like I said, definitely a lot of room for customization and making it kind of fit your NeoPixel strips. Or maybe you could use neon strips if you want to go that route.
That's actually the next comment I was about to highlight from John B on the Discord, asking they want to do a neon style project with strips. And Eddie Callaway said maybe a mini tree with nudes.
Ooh, that's a fun idea too. A little small tree.
So any of those,
totally.
Yeah. So that's again on the same thing that you were trying to explain on why you didn't do the clips. Any of those would fit to that model.
Yeah, I like the zip ties are kind of like a really quick and easy way to kind of attach something to something else. They're abundant. You can get them in different colors and different sizes, and it's really easy to just take these off now and take it apart, which is what I want to do.
Yeah.
All right, we got a question here from
Rawls. Is it possible to print 3 transparent parts on the printer? Yes, as long as it's
absolutely
like smaller than 1.5, right? And then on a glass bed, it'll come out super transparent.
The thickness,
not super, but pretty transparent. So
I would recommend
flat
printing
on a glass.
This is pretty much the prototype parts as well. So we have a lot of dark colored filaments. So if you want this to look better, I would recommend printing all of these pieces in like a white filament or a translucent filament. That way the LEDs just kind of, the parts would just kind of fade and diffuse into it. But you can really see these brackets here. But when you're documenting, maybe that's good because then you can actually see the part. You can actually see the thing being built. But again, this is kind of the prototype, but it's in its final form. It just I just stuck with these colors. But yeah, everything prints without any support material, which is another thing that I strive to do. So they're all going to print flat on your 3D printer bed. And yeah, you don't need any support. So they're all going to print on a relatively medium-sized 3D printer bed. Yeah, so let's take a look at the Learn Guide. If we have any other comments, we'll jump into those, but I'll quickly take a look at the guide after I share my screen here.
Up just some sightings from John B saying that they've seen some bare brass strips with the small WS28 12B breakout boards attached.
Okay. Yes, so the Learn Guide, the overview page, walks you through some prerequisite guides. So if you just got your Feather RP2040 Scorpio, you'll want to check out the guide so you know how to work with all of the different features, all the pin names, installing CircuitPython, et cetera. The NeoPixel LED library has some really advanced capabilities, so you can check that out. And of course, the LED animation library for CircuitPython, you want to check out that guide because there's quite a bit of animations you can play around with. I've only picked a few of them. We'll go through those once we get there, but it's really cool that you can kind of just quickly string together a sequence of animations relatively quickly. We have the Feather RP2040 in stock right now. Yesterday, if you got one, good on you because it was half off. It was $7 yesterday, which was amazing. And I'm surprised we still have them in stock. And there was a limit for 10 per customer. So I think a lot of folks got their hands on a Feather RP2040. The Perma-Proto board is going to help you kind of share power and ground and just gives you tons of pins that are connected, GPIO pins. So the small mint is a 3-pack, and I really like these because they're a little bit smaller than the half-size Perma-Proto and a little bit bigger than the quarter-size Perma-Proto, which I actually have one here. So I really recommend the small mint Perma-Protos. They're pretty nice. Unfortunately, the GPIO ribbon cable, that IDC cable, is out of stock, but hopefully we get those in stock. You can get these from other places as well. We just stock one that's like in this really nice black color because it's our favorite color. You got a couple connectors as well, like the 2-pin JST cable. This is good for sharing power and ground between the Feather board and the Perma-Proto board. And then, of course, you want to have an M3 nylon hardware screw set. Those are great for attaching boards and fastening things together. And then there's a slew of other things. The NeoPixel strips themselves, these are the special ones because they have the sheathing, the silicone sheathing plus the pre-soldered cables. That's really nice. Here you can see it photographed onto like I think a Halloween board. It just plugs right into it, and it has 30 pixels here, or is it 60 pixels? It says 60 per meter, but it's a half meter, so it's 30 pixels. All right, I get confused sometimes. But yeah, these are nice. You have a lot of flexibility with these two. You could cut them and splice them and all that sort of thing. But I like that they're just kind of ready to go right out of the box because a lot of times they're not. Those 3-pin JST cables, these are the sockets. So these will plug directly into these NeoPixels here because this is kind of the plug connector and this is the socket connector. And these are color coded as well. And they have, I think, like 26 gauge wire, which is good for passing, I think, like 2 amps, which is great for powering a ton of pixels. I've used these in so many different NeoPixel projects. So definitely get yourself a dozen if you are able to. Some 2.5 hardware kits, USB cables, a beefy power supply. If you do plan to power more than 200 pixels, you'll want a power supply that's more beefy, which is this one. This is a 5-volt, because NeoPixels like 5 volts logic, but they need more amps. And this power supply here has 10 amps, which will power a lot of pixels. Unfortunately, this one's out of stock. Hopefully we get that in stock, but you can probably buy it on DigiKey. There's a buy on DigiKey button. So if you want to pick that up, you can get it there. A DC power jack is going to work well with that power supply, and some nylon zip ties, which you may have them on hand. You can get these from an online retailer. And that's pretty much the parts in a nutshell. Let's go on over to the circuit diagram. So in this circuit diagram, if you are planning to use more pixels and maybe full brightness, you're going to want to follow this circuit diagram because it shows you how to wire up external power to the NeoPixels themselves. If you follow along with the Scorpio product guide, there's a lot of documentation on powering NeoPixels externally. So that's why we have it set up here. You'll also want to power the Feather separately from a 5-volt power supply. It can be like a 1 amp 5-volt power supply, like for like your phone charger or a computer's USB hub. That'll be okay. But if you're doing a lot of pixels, you're going to want that external power supply. So that's what we got there, and it's all written up here. These wiring diagrams are created with the Fritzing open source software, which you can grab off of GitHub. Or if you want it precompiled, I think you got to pay like a couple of bucks. But we like using it so much that all of these Adafruit parts are available as downloadable parts that work with the Fritzing software. And it's really easy to kind of drag and drop and create wire connections to these boards and components. And JP, John Park, our fellow Adafruiter, he loves using Fritzing as well. You can actually design and manufacture PCBs all in Fritzing, which is really cool.
He has a whole learn guide on that.
Oh, yeah, yeah. And don't forget, we got a link for Adafruit parts for the Fritzing. The next page is going to walk you through installing CircuitPython on the Scorpio board. So that just walks you through that. The code is available on GitHub. I highly recommend doing the download project bundle. This right here will download all of the libraries that are dependent on this code. You're going to need the LED animation library, and then the special libraries, the NeoPixel LED library and the Pixel Map library. So if you click that download project bundle, you'll get all of the libraries bundled with the project. So that's really nice. You don't have to go hunting for those. And of course, this was done by Jeff Epler. He optimized it to work with the NeoPixel LED library and the Pixel Map library, and it uses the PIO peripheral from the RP2040 chip. Some of the things you want to do to change and customize the code is right here. We have the length of the strips called strand length. So you have more pixels. Let's say you have the 60 pixel strip. You'll want to update that. Pixel brightness is a global variable you can change. Right now it's 0.8 brightness, which is like 80%. 100% would be 1.0. How many strands do you have? We got 8. And then this is some of the NeoPixel object stuff. This is some of the code to define kind of the length of the strand. And then here we're defining just some variables for our different strips. So each strip is kind of labeled as a letter. So A through all the way through H. And then here's where we're creating our animation sequence group. So right now, this is using the rainbow animation effect from the LED animation library. There are some parameters you can change here, like the speed and the period of the duration of it, of the rainbow. And each one of these strips have are kind of written out here. So you can see A through H, they're all kind of doing the same thing here. And then to do, a sequence, you just kind of use a comma and then you add another one. Another animation group here is the chase animation. So you can see here when the LEDs are going up and down, those are chase, and you can change things like the spacing and the color, as well as the size. So all of these numbers can be adjusted to kind of create a completely different effect. So you'll see here that some of the strips have different colors. Here I'm using red, white, and this jade color, which is like a green. And then some of the spacings are a little different, or actually maybe they're all the same. Well, some of them are different. Some of them have 8 and some of them are 4. So just kind of creating some variance. So just one small tweak to the size or the spacing will create a completely different effect when grouped together in this display here. We're also using the Comet. The Comet lets you do a nice dithered tail length, so you can define the length of the tail, and you can do things like, do you want it to bounce up, go back and forth? That's the bounce attribute parameter, and you can tell that you can define it. You can say true or false, basically. Do you want it to bounce or not? You can also say reverse. Do you want it to go in reverse? And you can see here sometimes it's bouncing up and down, and by using the reverse true, you can create a cool effect that way. Each pixel is being being driven differently with a different color and different reverse and bounce parameters. And then after all of that, you can say, what is your interval? So if you want to make it longer or shorter, you just change that value. And then there's an auto clear, which is, I think it's optional, but we just have it there just to make sure that the animations clear out when they are done. And then in the loop, all you got is animations.animate, because all the work is really done here. So if you're an advanced coder, you could probably make it so that you can reduce the amount of code, but I have it just written out explicitly, like just every strip, and I'm just defining the different animation, which makes it look a little hairy, but that's just one of the ways to do it. So that's the code in a nutshell. Here's a screenshot of what your USB drive looks like. One of the awesome features of CircuitPython is you plug it into a computer's USB drive. The code and the libraries are accessible, and that's how CircuitPython works. Unlike some of the other coding platforms, CircuitPython is amazing that you can just access the code and libraries on any computer with a USB drive. And that's the code in a nutshell. The CAD files, I have the source files. So if you want to use the step file, go ahead and download the source file, or the Fusion 360 file, which contains like the original sketches, the timeline. It's parametric as well, so you can update the diameter and the sizes of the thickness and all that. And then we have STLs that are ready to go, oriented as is. And you can see here that you're going to need to print 8 of the brackets. I have the brackets set up in different letters. And one of the things I like about these brackets, or rather these slats, is that I have embedded labels in them in the model itself. The first layer has either the letter A, B, or C, and that lets you know right away at a glance what part that is, because they kind of look the same and they're a little bit hard to distinguish from each other. So I think if you're designing something that requires a ton of parts, it's always good to bake in a letter, a label into your part so that you can right away see it. Sure, you could label it with a marker, but that's going to rub off. Like, let's just be honest, it's going to rub off. And that's why I added labels into those slats.
Yeah, one thing we want to test, I saw Prusa post that they have a text tool now inside their slicer, and I was like, hey, maybe that's what this could be used for. You write the text right on there, so you don't have to bake it into the STL. You just put it on there as you do the slicing.
That's a good idea too. If it works
you can
out,
like place it on the actual face that you need it to, like it's just not a floating text.
But then your STL, you won't know what's, when you drag it into your slicer, then you're not going to know.
I mean, it tells you the name, but yes, you could.
True.
Yeah.
Yeah. So there's options, right? I just baked them in because why not? Another thing I want to note is the build volume to print. The biggest part is the I think it's bracket B. Yeah, bracket B is the biggest part. It's going to need a minimum build volume of 195 millimeters by 195 millimeters. The Z, most printers are going to be bigger than 50 millimeters, but all of these parts are probably like not even more than 10 millimeters on the Z, because they're not really tall prints at all. They're just long prints. And they all feature M3 sized, slightly bigger than M3, just so that you can get those hex nuts in there. So those finger joints there on bracket B are a little bit oversized, just to accommodate for so that the screw can just be inserted instead of like having to tap it. And I guess that's kind of the nutshell. They're all ready to go, ready to print as is. They're oriented or ready to print flat on your bed without any support material. And then we have some design source files like the Feather RP2040 board itself. We have STEP, STL, Fusion 360 formats for the 3D model of the Feather. And of course, this right here, this download link will give you the source file for the snap fit case for the Feather, the snap fit case for the small mint Perma-Proto board, and the tree design itself. So all that's there for everybody. It's a completely open source design, and we want folks to make it their own. So we might as well give you the source. Over onto the wiring, I'm going to kind of run through this a little bit. The Scorpio comes with a few different flavors of headers for the PIO peripheral for doing the NeoPixel driving. I like the right-angled header, so I have that. I'm using the 2-pin JST connector so that I can plug and play into the Perma-Proto board. Now, the Perma-Proto, I have here the IDC cable, right? That's that nice cable that has that 2x8 kind of socket. And I have it here photographed and labeled so that you know the orientation of the wires. So let me do a quick overhead shot. I'll have to stop my screen, present, and share my overhead screen so folks can see. You kind of have to manipulate this cable a little bit. So this is the notch. Normally, this would be keyed, but the Feather isn't really keyed. I don't have the thing soldered in here, but this can go in either way. But what you want to do is you want to use this marking. There's a little white marking here on this cable, and that is the identifier for NeoPixel number 0. NeoPixel number 0 is going to be this guy over here. So when I plug this in, I want to make sure that this wire lines up with NeoPixel pin 0. So when I have this plugged in like that, I will know that this is correct. And the thing about these cables is like, well, okay, so I only need 8. I'm not actually using any of the ground pins. All of these down here that are in this white label are actually ground. You can kind of see the negative pin there. So what you got to do is you actually have to cut and separate these wires, and it's every other wire that is the right row of pins here, because this is the row of pins you want to use, not the ones at the bottom, because those are just ground. And because of the way I have it wired into the Perma-Proto, I don't need any ground pins here. I only need the digital signal pins for the pixels. So that's why I have it in this arrangement here where I'm like, I cut away every other wire. So that's kind of how the setup is. Yeah, so you want to be very cautious about how you're setting up your cable. Yeah, what's up?
I didn't realize that was a whole row of grounds.
Yeah, right. And
I would like to request to Lamar every freaking Feather have this.
Right, that is very nice. For a lot of projects, you want ground pins. Are you
kidding? Holy crap.
But what's funny is like I didn't need them in this project because I have all the grounds in the Perma-Proto board. When you got a Perma-Proto board, you can just wire in a one ground pin to the Feather, and now you have like a bunch of ground pins, and then you can combine these two together if you like. But yeah, you can see here how they're all how Perma-Proto boards work. You can just flip it on the side and see you get a lot of shared connections on the rows and the columns. So that's just one little insight there. Let's head on over back to the Learn Guide and try to wrap it up here. Present my Chrome tab. Where'd it go? There it is. And we'll bring it in. All right, so that just walks you through all that. Here's a photo of the Perma-Proto fully wired up in all its glory. Here you can see the small mint has a little bit of a different layout. All of the ground and power ends, all of the voltage and ground pins are in the center. A little bit different because the one I just shared you has them on the edges, but the edges here have kind of these connected signals. So for these 3-pin JST cables, the white color is the signal. So the signals are all going to the IDC cable here. The red is voltage. They're all going to this voltage ground or this voltage rail that goes into this pin here. That's the socket style 2-pin JST connector that plugs into the Feather. And this actually connects to the USB pin of the Feather because I'm only using 200 pixels. I don't need external power, so I'm getting all my power from the USB power from the Scorpio, which you can do, but it's limited to, you know, less than, let's say, 300 pixels or so, and not max brightness. And then all the black wires here from the connectors are going into ground, and then this ground pin is going to go to the ground pin on the Feather Scorpio. All that's documented, and you got a nice photo there, but it's all written out there like that. And that's pretty much the wiring for this particular project. As you can see here, I have a note for small LED projects. This is the way to wire it. But for large LED projects, follow the circuit diagram where you're using the external power supply. And then the wiring page walks you through step by step assembling the base. So that's brackets A, how to install the hex nuts, how to fasten them together so that you get this nice giant base. And then installing the slats, there have these tabs. The tabs get press fitted into these finger joints of the bracket B. And then you can see here that there's a nice hole there for the M3 screw to fasten into. You want to do that for all 8 of the slats. And then once that's assembled, you can start press fitting in these little ends into the slot, into the square peg holes of the bracket A. And then for bracket C, you want to get slats B and C joined together in those finger joints. And everything just kind of gets angled correctly as you're assembling it. Like, it's funny how, like, the way the finger joints are laid out is like they're just gonna fit right into place. So the angles just kind of work out when you're assembling it, which is kind of amazing. Nice. And then the last bracket is this top bracket. Slats C have these drafted angles, and the top bracket has corresponding angled edges so that the slats can't pop out. This was actually an idea from Jeff Epler, because at first they were just straight edges, and like you would have to kind of like glue it, but because you just angled those edges, it just gets it just stays in place because of friction and the way the physics work. And so huge shout out to Jeff for that one. I wouldn't have thought of that otherwise. It's a really interesting something easy to do too, is just if you just add these little angles to your edges, the thing won't pop out. It's just pretty cool. Yeah. So that's the top bracket. And then near the end of the assembly, you want to get your NeoPixel strips, some zip ties, or if you want to do a more permanent approach, you could use some sort of adhesive or 3D print your own brackets, however you want to do it. I chose just to use zip ties because it's easier and it's more kind of open-ended for a different NeoPixel strip. It's more universal. Thank you. The NeoPixel strips are going to vary, so that's why I chose to go with the zip ties. Yeah. One note here, don't over tighten your zip ties. That's easy to do. You kind of want a little bit of slack so you can kind of move the zip tie into place and just kind of strategically lay them out so they're evenly spaced. And I recommend using white colored zip ties if you want to go that route, because they really stick out here. But it works out here because in the photo, you can see it. So I got lucky there.
Yeah, that's one thing. Yeah, we sometimes print in like neon green just so it's visible for the parts for the learn guide.
That's true. Yeah. Yeah. And then pretty straightforward to get the a case for the Perma-Proto. I'm using these long M3 screws and hex nuts to fasten the Perma-Proto. I like this Perma-Proto. The small mint has 4 mounting holes. The other ones only have 2, and they're kind of a little bit different sometimes. So like this one here has only 2 mounting holes. I love me some mounting holes, so that's why you get 4 here on the small mint Perma-Proto. That's just the way Lamar designed it, which is nice. We also got a snap fit cover for the Perma-Proto case. It has like this large opening, so you can fit the connectors through that, and it has those snap fit edges that I really admire and use a lot. So it just stays in place without any screws there. And then we walk through the securing the Feather Scorpio to the 3D printed case. There's a slot here on the bottom of the case, so you can pass the 2-pin JST connector through, and then you can use 2 screws and hex nuts to attach and secure the Scorpio. You got a cover there too if you want, and then connecting the Perma-Proto board to the Feather, you just plug and play. And then you're gonna want to be careful, depending on your art project. If it's just the tree, it kind of doesn't matter which pixel gets plugged in first, but you do want to reference that white label on the IDC connector so you know which pixel is the first pixel. But because we are in code land, the first pixel is actually number 0, because that's how code works. And then just you want to do it consecutively. So if you want to do advanced animations, you kind of want to keep track of which pixel is next to the next strip. So just be careful and follow, you know what I'm saying, right? You just follow your wiring so that it's consecutive. Yeah, and then I'm plugging in the USB power supply to the Feather Scorpio, and they all should just power on and start animating. Definitely recommend a 5-volt 1 amp power supply like your phone charger. And depending on whatever USB-C cable you have, it could be a Type A connector or a Type C connector. It's up to you. But that's the wiring and the assembly in a nutshell. Try to keep it as modular as possible. So that's why we did a couple different design decisions that we talked about already. But that is the holiday tree. Awesome. There it is, still powering. And it just kind of keeps looping and cycling. And we can add more animations if we want, change up the colors. Maybe we do some sort of cosplay prop. And there's a dog. And there's a pooch. We have a dog cam now. Yeah, I'm sure this could be adapted for some sort of like kind of like a cosplay wearable or something. Maybe it's like a shooting prop.
No, there's a ton of
wearable.
Stuff,
like, yeah, some sort of mask.
The first thing that comes to mind is a LED video skirt or a curtain.
Oh, that's funny.
I think that's what Toby actually did when he was testing it all out. He made a curtain. But skirt,
yeah, I mean, this could be just a cool light fixture. Imagine, some sort of lampshade, some sort of, a lighting fixture of some sorts. Just turn it upside down, and it's something else. You could put these strips in all sorts of different ways. Maybe a ball or something. Which holiday? Groundhog Day? Yeah. Madable had a great one. Yeah.
I think everybody. Yeah.
Oh, it's a volcano. It's a volcano. It's not a tree. Yeah. It's a
part
volcano.
Of the dino set.
Part of the dino set. Yeah.
Before I forget, you were talking about the USB-C cables. I got a USB-C hub where it's just USB-C.
Oh, that's cool.
Where it's, finally, it was like $60, but it's powering all the stuff here. When you have like a MacBook with like one port, it's got it's going with the 2 cameras, the microphone, the that out for the HDMI, the phone.
That's great. I need to get one too. But the whole thing about the Scorpio RP2040 is to create art displays, lighting fixtures, cosplay props, whatever your heart desires. And I think the hardware now makes it a little bit easier to kind of drive a ton of NeoPixels with the right power, of course. And with CircuitPython, you can really do fast animations now combined with the NeoPixel 8 library. So definitely check out that demo code if you are just getting started with these CircuitPython LED animations for NeoPixels.
So when you were talking about the fritzing stuff, John was asking, Johnny B asking, is fritzing hard to compile on Windows? I don't think so. Is it?
I'm not sure. Maybe there's some documentation. I think we purchased it and we've just had it ever since.
Yeah.
It's one of those softwares that's like a legacy software. Like once you get it, you don't even need to update it because it just kind of works. That's kind of nice.
Another good comment from DJ Devin saying that followed the Snapfit guide for his printer. The 0.2 millimeters tolerance wasn't enough, so he just has to keep in mind 0.3 or 0.4 for the tolerances. So
that's a good opportunity to turn your offset into a user parameter. That way you don't have to modify a sketch or modify a feature. You can just flip a switch in the user parameter. Definitely check out the user parameter feature in Fusion 360 to make it easier to update your tolerances.
Yeah. Another tolerance difference too that you should take note of is when one 3-part is going into another 3-part. That's where I know my tolerance is 0.35. So I need two things to match together. It's not 0.2, it's 0.35.
Yeah,
there are differences in what the tolerances will be depending on what you're trying to snap fit together.
Yeah, orientation matters as well. So if you have a hole that's printed in the Z, is going to need more offset, more clearance than a hole that's printed flat down on the bed. And we need a break. We need a cute pup break. That is a Saluki mix dog. Lovely breed.
It's been making the internet rounds.
He can do it for you. He can do it for you, Kermie. What a great specimen.
Oh my god, the resolution on this Brio Logitech camera, does it look super sharp?
It's super sharp. Yeah, I can see like the texture in the carpet, and his ears have like these natural crimp texture on his ears. Very cute canine.
All right, switching over to what are we prototyping?
Yeah, we have 10 minutes. I took my time on this one. I apologize.
All right, let's go ahead and quickly look at what we're prototyping. See if I can get this done in 10 minutes. So Lamar found some really good inspiration for a really cool rocket lamp. And she was like, okay, we can remake this thing, powered by CircuitPython with the Feather RP2040, a PropMaker wing, which I didn't even know the two work together. And of course, some NeoPixels and the rings and all that. So what it is a white noise rocket lamp. Got this really cool rocket switch. Turns on with the LEDs and everything. And then you have hugs to Liz for writing this up, having all the code work beautifully. There's a fan inside here that moves the flames. You can kind of see it. And then she has a rotary encoder that has multiple modes. So when you push down, it'll switch into the brightness mode. So you can adjust the brightness, push again, and you have audio. So this is a recording of, I think, one of the Voyager missions did a flyby of Saturn, I think. And you can control the audio from there. So there's a speaker and all that. So you take a look inside. Sneak peek. You can see the Feather and the NeoPixel ring, the speaker and everything is all mounted inside quite nicely. And then, of course, the other thing is the way it balances. I won the Maker lottery on having this balance so good. I thought it was going to flop right over. And super cool way to make a lamp. Of course, both I have to make like 3 of these now. But
you went for each kiddo.
I don't know the way that all of the
that's cool. So the rocket's umbilical cord is like housing the wiring, which is great.
Yeah, snap fit. Whatchamacallit?
Oh, the battery. There you go.
You can see everything's all connected in there. We're using, to read everything, we're using the DIY ribbon USB cable. So we have a socket one inside there.
Oh, nice.
And then place that up. And this just press fits in on top like so. Get a nice little like taper on there, so no snap fits on this. I was trying to keep it minimal, so when the LEDs glow, you're not seeing like all the snaps and all that in there.
Yeah, that's true.
And yeah, this is a really cool way to remake like a lamp, toy, audio, and of course the fan. You can kind of see it on the inside there. It's just a 5-volt fan. One of these little guys. Was a little funny in terms of some of the gotchas that happened during the project. One of those gotchas is, if you can look at the wires here, you can see the way that this is split up. It's going.
Yeah.
So you
ground goes into like voltage. Voltage goes into ground.
Like, what the heck, guys?
That's
wild. Oh well, there's a couple of instances. Like, we'll talk about that next week. We'll release this guy next week.
Sure. Yeah.
This is a really cool rocket lamp, white noise. I think I've mentioned it last week. Gavin has gone through so many of these. I forgot to grab what the latest one is. Has like a sip and puff. So it's like a rubbery gear.
Squishes.
Push on it. So yeah, when you squish it, the air from it, like the sip and puff picks it up and it changes the color and the brightness. So that's super cool. Cool way to add interactivity with just air. So cool. So yeah, cool little switch here.
Yeah.
Turns off. And you got the USB-C in the back. You can plug this into the wall or just have the battery powered. And
I love the use. Yeah, I love the use of the Stemma QT rotary encoder, because you have an onboard NeoPixel that can give you status, so the mode selector, and then it's so much more robust than like a potentiometer, because you could just keep dialing that knob until you reach your max brightness or max volume, or you can go crazy and control the fan as well. You could go in there and add a bigger fan, like a desktop PC fan, if you really want that flame effect to like, you'd have to redo the rocket, but I'm sure people could just use the parts and the code and like make it your own. Like that's the whole thing about these open source projects and hardware. Very, very cool.
Yep, just filming that. I think the only thing I want to add on, there's maybe a window in here. Let's see how that looks. It might look funny. Maybe if I it's like a 0.5 millimeter. So it's something like how this, we were talking about this earlier, where it shines through because it's so thin, so I'll try to do that. And then other than that, maybe Liz can add a third function. Remember the night watch, little big sister, the goggles? We had added a mode where it goes through all the colors.
That was cool. That would be cool.
That'd be kind of cool. Yeah. Look at the what
it might be outside the scope of the project, but we can ask. Maybe it's easy to do. Yeah.
If it is.
We're not super advanced coders, so we're not sure.
But I know it Philby rated in Arduino, so maybe not.
Okay.
Might not translate.
No, it's CircuitPython.
Maybe Jeff can take a look at it. Have that added in there. That'd be pretty cool. That'd be nice to have it just goes through the color wheel,
Yeah.
Fancy.
A lot of folks should know, like a lot of one of the difficult things about working on Adafruit Learn Guides is knowing when to stop. And knowing when to stop is very important for us, because we do working.
I know, that's why I didn't have the window.
But if you're a parent or someone that's passionate about writing software and developing, this can be your project. You can expand it as much as you want. But as people, we need to know when to stop, and like we try to constrain ourselves in a way where we can get it done in either 2 weeks time, 1 week time. We need deadlines, and we got to let the community take it on and make it their own. Yeah. So I just thought I'd say that.
No, it's a good point to bring up. Like I wanted to, I was right in the middle of shooting, and I was using the little mini boost, and I was like, well, I can't figure it out with the code, so I need to shoot this. And in the middle of shooting, Liz fixed some code on it that made it work without having to need that boost. And I was like, crap, well, now I have to stop what I was shooting because that's one less part, but it makes it that much better because to me, it felt kind of weird needing an extra boost to get it to work.
Yeah,
it's code you can get the fan to work. So even knowing when to stop, go back and redo something, it's totally worth it.
Exactly. Yeah, and it saves at the end. It saves people soldering and money. Like you don't need to spend that extra $10 on or $5, whatever it is.
Yeah.
You can save some money on the BOM, on the bill of materials, by just leveraging the existing capabilities of the PropMaker FeatherWing, like those RGB pins. You would think like, oh, the RGB pins are only for RGB LEDs. No. You could power high voltage things like a 5-volt power, like a 5-volt fan, which is what we did here.
That's why I stopped and was like, okay, we need to try to get this to work. So that is definitely definitely handy.
Cool.
Right, and that is that's what that is what we're prototyping this week. We'll release this next week.
Next week? Oh man, that's gonna be fun. Yeah, it's gonna look fantastic in the low light settings because right now your room is very well lit and it's kind of hard to appreciate the way the fan illuminates its environment. Is like, okay, this is super cool. I love seeing it in a dark setting.
Yeah, it'll be a Declan's for. Hopefully, he can act and act like he's sleeping. I'm gonna shoot it in his room with his desk and everything. See how it illuminates everything. See how that works out for. How the saying you shouldn't have babies in the the videos, but I'll try it out. See if he can act.
No, he's not a baby anymore. He's 3. So.
Yeah.
Our little boy. All right, cool. Well, let's switch gears over to the next segment of the show. It's community mix.
Is Sleeping Puppy Cam.
Sleeping Puppy Cam. He's still sleeping. That's great. That's just a still image. No, it's a real dog. I'm going to take this break to also mention we do have a 10% off coupon code. Help us feed this poor dog. With coupon code Scorpio Tree, you can get 10% off your order. Oh, he woke the dog. He's fine. He just was dreaming. There you go.
Plant's not dead.
Segment,
it's flowering.
That's funny.
Let me get one that
you got a green thumb, man. People probably don't know. Pedro's quite the botanist over here.
They're getting to a size where I can almost bring them in here, and I want to show off how big one of my plants is getting.
Alocasias,
so good. Oh no, it's the Anthurium regale. Looks so good. Oh my god, it's like, oh, you can't see my face. Where am I?
Oh yeah, let me hold the
bigger my head.
You're right there. Oh, Poochie. Good puppy dreams, everybody.
Oops.
Yeah, what are you doing? I want dog.
I'm trying to get to my face. All right. Oh, it's already showing. I need a third monitor. All right, cool. Community makes. Oh man, we're gonna have to save it for next week.
Are you sure? I could do overtime. That's fine.
2 minutes.
I mean, if you really got to bail, you're probably starving.
About Anthuriums.
Oh yeah.
Yes, this regale, and that's why I'm like so proud of it because it grew in 40% humidity. What?
Oh, wow. That's the next show.
What?
Plant
even have some work
plant hangout
queens that I'm growing in 50 and 60% humidity. They look so nice. Oh my god, I'm so surprised.
That's great, man.
Where am I?
All right, let me show. Yeah, real quick, man. We got a dog coat rack.
Okay, yes.
This was super cute. It's a paid design, but we like paying designers. This was by
it was like on sale.
Not by KitKat, man. Why do I get these ads? You get they gotta pay for the server. 3D Printables by Lucas designed this really cute dog coat hanger that has like a bit of a mechanism there. So it's assembled. The tongue the ears, they all snap fit into the canine's cranium. And then you can use a rubber band to act as the spring so that it opens and closes its mouth when you hang something on it. Is that right?
That is correct. This looks so cool. Let me get him off this little stand here. And yeah, it looks.
Did you
like
paint
Scorpio.
him?
Yeah,
Did
his
you paint
eyes.
the dog?
Yeah. His eyes are painted. Try to get that little reflection thing in the eyes that you always see in anime.
Cool. That's funny. Love puppy dog eyes.
Bark.
It's great that the ears move. It's very cool
Yeah.
mechanism. Definitely check that out, folks. It reminds me of like those little grabber things, like the T-Rex head, you know, or the Pez dispensers.
Yeah. So there's a rubber band in the back. That is bringing it back up after it doesn't have any weight on his tongue anymore. So that's what's actually making it work. As soon as the tongue goes down, it'll grab down on it, and then there's this little lip here that prevents. I'm using it as his harness holder. So like clamp down on it.
Actual dog.
Yeah. Yep.
That's very cool. Yeah, I love looking at these mechanical designs.
Yeah, so we're using the wood fill PLA for this. So it was quite stringy. Yeah. But that's the only brown color I had.
Interesting. Yeah.
You can kind of see the tongue here. It gets pulled back, or it pushes actually. Here the lever acts like as a lever. And then his ears, I think they get pushed right here. You can kind of see it.
Oh yeah, there's some sort of flange.
The way that the mechanism, the way that works. Yeah. Super cool, interesting. And the name of the designer escapes me.
No, I said it. 3D Printables by Lucas. It's on Colts 3D. It's a paid design. It's about $3, but very, very good design. Did you need any support material?
I got it. Really? Did I need support? No, I did not. No supports.
Oh, excellent. I love that. Cool. Yeah. And then some paint if you want to add some detail.
Oh, yeah. Yep. Have a little pink nose and all that. And then he has two versions.
One with
one mount, and then one with the other one. You can kind of see in the video that it can kind of rock. If you don't have that second one. Both of those models are available on his profile page. Oh, wow.
Yeah. Oh, wow.
Oh, I didn't color his collar. Dang it.
Oh, it is his collar. That's a lot of detail. Very nice. Good pooch.
Let's see what just kill 1 minute of time with. Let's see.
Back to dog cam.
No, I was going to put it up to him. Wanted to get his reaction.
Oh.
Yeah. Are you going to rub my belly?
He lifted his leg.
He wants to have his belly rubbed.
Yeah, he does.
It's like, that'll cost you.
All right. We got some other community makes, so let me run through those. I'll do half this week, and then we'll do half next week, huh? All right. First up, we got this. I know. Let me do it real quick so we don't have to do it next week. All right. The DIY on air sign. That's a make that was posted up by Thingiverse user was Zuber. And it looks great. You can 3D print this case. It's got NeoPixel strip in the back and some vinyl to make this piece of acrylic diffuse nicely. And it says hacking. Looks really nice. Next up, we got a very custom 4-button keypad that's in the shape of a kitty paw or maybe a dog paw. And Jorge posted this up on Printables. They remixed the design to not have the TFT display and just have a regular paw in the center there. And it has a NeoPixel as well, so it illuminates. And that's just the cutest little keypad. It's a freaking paw print. Doesn't that look great? That was great. Yeah. So huge shout out to Jorge for posting that up. Looks great. Next up, we got another LED emerald with the Circuit Playground. This was inspired by the Sonic the Hedgehog franchise, and this was posted up by Maga3 on Printables. They printed it in a green PLA, and they're going to add the light later, which is great. You don't have to add the light. You can just print it in green. It looks fantastic.
Oh, that filament looks excellent.
Yeah. And then the last one is the Scorpio case, the one we posted last week. Prusa user MCKO posted up there. Looks like it's fresh off the 3D print, the 3D printer. It's the SnapFit case there for the Scorpio. And we appreciate everybody who posts up their makes. We know it's, you know, it takes a little bit of effort to post up those makes. But that's this week's community makes. We did it. Did it real quick, and then we'll have more next week. Don't forget, you can support the show, Lamar, Lady Ada, Baby Ada, the whole team by ordering stuff every now and then from the Adafruit shop. We hope you find this show valuable, and we got a discount code for you to save a little bit on some money. So 10% off discount code this week, Scorpio Tree.
Yay.
That's it for the show, folks. I'm going to go back over to Discord and wish everybody well. We hope to see you later tonight on Show and Tell. Show and Tell is going to be hosted by Mr. and Mrs. Lady Ada. So it'll be a really fun time to catch up with them. And then Ask an Engineer is at 8 p.m. Eastern Time. Back-to-back shows. I hope to see you folks there. I want to see some projects. I think I'll come on and bring the thing here.
Yeah, I'll come on and show the tree just because Lamar and Phil are there.
Yeah, totally. Thank you, everybody in the Discord chat for hanging out. Big shout outs to DJ Devin, Du Wester, Yanni Sku, Jim Hendrickson. You guys are awesome for hanging out with us during this show. We know it's a weird time zone, but appreciate everybody for hanging out and listening to us.
If it's the morning, nice to have coffee too, I hope.
Yeah, it's a global show, so we know people everywhere are watching. So everyone on the archive watching the show later, big shout out to you as well. So that's going to do it for us this week. There will be another coupon code later tonight on Ask an Engineer. We'll see you next week. But until then, remember to
make a
great day. Bye, everybody.
Good night. See you later tonight.
Bye.